Okay, this is the review for Unit 4, and it is primarily about area, Riemann sums, and U substitution. Okay. All right, so the first thing you want to do here is find the area. If you're asked to find the area and there's just a bunch of geometric shapes, the only trick is that you need to pay attention to whether you are above or below the x-axis. So here these shapes all happen to be triangles, but they could be semicircles, equilateral triangles, right triangles, doesn't matter. So for this one, we're just going to use the formula area of a triangle is 1/2 base times height. So the first triangle I have in yellow because it was above the x-axis. Okay, so I just did 1/2 base times height and got 8. For the next one from 4 to 6, that's this triangle down here, that is going to be a negative because it's below the x-axis. So we're going to say negative 1/2 base times height. Here the base is 2 and the height is just 1. So when you multiply that, you get a -1. For part C, it was the area of just this rectangle, this triangle. It's going to be 1/2 base times height. It's above the x-axis, so I don't need to worry about anything being negative, and I got a half there. So to find the area of the entire interval from 0 to 7, I'm just going to take those 3 pieces and add them up. So we have 8 minus 1 plus a half, and then you add those up, right? You'd get 7.5, right? So you'd have 7.5, or even better, I like 15/2. All right, moving on to the next one. So calculator, estimate this, okay, with this. Now, keep in mind that your calculator is more going to be to help you with the arithmetic on this problem. Your calculator can help you find the exact value of that, okay? But if it asks you to calculate with the left or right, or midpoint for that, it's more, and it's on the calculator, it's more just to help you with the arithmetic. So the first thing you want to do here is figure out your delta x. So in this problem, delta x, right, you do top minus bottom divided by however many subintervals you want. So here it's 1 minus a -3, and it said 4 subintervals, so that's why this 4 is here. And that means that the width of each rectangle here is going to be 1. Okay, so the width of the rectangle is going to be 1. And from there, we are going to kind of, you can think about like, what does that mean for the rectangles? Well, that means I'm going to have a rectangle that's from -3 to -2, right? That'll be rectangle number 1. Then I'm going to have another rectangle from -2 to -1. I'll have another rectangle from -1 to 0. And then my fourth rectangle would be from 0 to 1. So if you kind of break it up in that interval, it makes it a little easier to see that you do indeed have 4 of them. 1, 2, 3, 4. And now I'm going to kind of use my formula. So again, it's this thing is approximately, because Riemann sums give us an approximation. And with the left endpoint Riemann sum, that means I'm going to be using this number, this number, this number, and this number, because that's the left of each one. So it's going to be delta x times what I get when I evaluate there. So it's going to be 1, that's easy, because that's my delta x, times, well, what do I get when I plug in a -3? Okay, so when I plug in a -3, 2 minus a -3, well, that turns to a plus, so it would be the ln of 5/3. Okay, and then plus, now I have my next one, so it's 1 times, now I'm using the left endpoint of this rectangle. Well, the left is going to be -2. When I plug in a -2 there, it'll be minus a negative turns to a plus, so it would be a 4. So you're going to have this, the ln of 4/3. Now be careful when you are putting these in your calculator. You're probably going to want to put parentheses around there, like that. Okay. Plus, I'm on rectangle number 3 now, so I'm using this -1. So my width is still 1, right? Going back to that delta x, you have the width of the rectangle out front multiplied by the height of the rectangle is what's given when you plug in. So this one's going to be the ln of 3, right? 2 plus 1 is 3/3. And then my last rectangle will be 1 times the ln of 2/3. Right? Because when I plug in a 0 there, I still have a 2. So then, using your calculator, you're going to carefully type that in to get your approximation here. And if you type that into your calculator, you should get 1.596. Okay, so just make sure you're being careful. If you need to use a couple different steps to kind of break down those decimals, that's fine. So that's what I got with that. Now remember, your trapezoidal sum is going to be a slightly different formula. Okay, so your trapezoidal sum will be slightly different. Hold on, I want to make sure I'm still recording here. Okay, for the trapezoidal sum, okay, remember there's a slightly different formula there. Yes, you need to know that formula. It is not given to you, so you'll just need to know it. And for this one, we're going to say that, again, this interval, or that integral there is approximately, okay? So the trapezoidal formula says it's 1 over, so that'll be a half there. Okay, because that formula is delta x over 2, and in this case my delta x happened to be a 1, so I have a 1/2 out front. And now I'm going to have to say it's going to be ln, okay, it's going to be 5 over 3, okay, plus, now it's going to be f of, I have to do 2 times f of, well, what do you get when you plug in the next thing? So it'll be that -2. Well, remember, when we plugged in -2, we got a 4, so it'll be ln of 4, 2 times ln of 4 over 3, okay, plus 2 times, what did we get when we plugged in a -1? Well, when you plug in a -1 there, you get a 3, so it'll be ln of 3 over 3, okay, and again, when you're using your calculator, you're going to want to double up these parentheses there to make sure you're good, plus 2 times ln of 2 over 3, okay, so let's see, that's 4, and I should have one more plus the very last one, right, because when I plugged in 0, that gave me the 2. Now I'm plugging in 1, okay, when I plug in a 1 there, this will just give me a 1, and remember, the beginning and the end don't have that 2 there in the formula, so this will just be the ln of 1 over 3 there. So you put all that into your calculator, and when you plug that in, you get 1.328. And again, how could this look? They could ask you to figure out the exact with your calculator and then ask you which one of these was a better estimation. To that, you'd have to use that Math 9 and enter that all in there. But it didn't ask me for that, so I'm just going to stop there on that page. Okay, for number 3, again, this is a calculator question, but your calculator is not going to actually help you find the integral. Again, you don't even have anything there. So what they do is they like to give you this table here. My recommendation, when they give you a table, usually it'll say something like using the intervals given. So that means that you're going to have a rectangle like this, a rectangle there, and a rectangle here. So this is basically saying that you have 3 of them, 3 subintervals over this, and we're trying to use the right end point. So to figure out the right endpoint, so of this rectangle, this would give us the right. Of this rectangle here, this is the right, and of this last rectangle, this is the right. So that's why I like to kind of draw those rectangles there. It helps you see. So if I'm trying to figure out the interval from 0 to 12 of RT dt, that's going to be approximately, well, remember, it's your delta x, the width of the rectangle. Normally it's the same number, but when you're given a table, it's usually not, because look, from here to here is a distance of 2, okay? So it'll be 2. Now, since I'm using the right endpoint, I'm going to use the 25.8, okay, plus, now the distance here is a 4, and I'm using the right endpoint, so that's 13.2, plus the distance this time is a 6, and I'm going to use 33.6 there. And then you could type that all into your calculator, and if you type that in correctly, I got 306. Okay, is my estimation for that one. All right, next is going to be a variety of integrals. So some of them require u substitutions, some of them do not. This first one does not. So remember, your goal, if it looks like you could use the power rule to take the derivative, then you could use the power rule for integrals. The power rule for integrals just says that you add 1 to the exponent, then divide by that number. So that's exactly what I'm going to do. These here are indefinite integrals, which means I will need the plus c at the end, so don't forget that. So for this one, you're going to add 1 to the exponent, divide by that number, add 1 to the exponent, divide by that number, okay, and then add 1 to the exponent, divide by that number. Here, if you just have a number, you're going to tack on a variable there, and then a plus c. Yes, you could rewrite this as just a -2 there if you wanted to kind of clean it up, but that is your safe step. But if you wanted to go one step further and risk the algebra, you can indeed clean that up for that, okay? All right, I'm just going to kind of work horizontally here. So for this one, a clue that you would need to use substitution, you've got parentheses, right? And if you kind of think about the derivative of those parentheses, you kind of see that 4x, so that's one clue that you need to use substitution. So here you have u is whatever is in the parentheses. That's my general rule of thumb. So I've got that. You want to take the derivative of u with respect to x. So the derivative here is going to be -4x dx. And that's good news because this -4x and that dx is going to be exactly my du. So when I go to rewrite this, that's going to be equivalent to the integral, okay, of u to the third du. And now I can indeed take the integral of that. So when I add 1 to the exponent, divide by that number, okay, plus c. And then at the very end, I'm just going to go back and substitute in my u, hence why it's called u substitution. So we have that to the fourth, all over 4, and don't forget my plus c I got to squeeze in at the end there. Perfect. All right, for part B here, I would recommend probably rewriting this and breaking it down, okay? If you have something divided by 2x, I would rewrite it so that each piece was divided by 2x, and then I would just use the power rule. So to kind of indicate that, I would still say this is equivalent to the integral. Notice, like, left that integrand there because I'm not taking the antiderivative yet. I am just kind of setting the table, getting ready to integrate. So plus 4 over 2x dx. Okay, so there's me getting ready. I would probably even clean it up because it's going to make my math a little bit easier. So again, I didn't take the integral yet, so I still have that integrand symbol there. So that's going to reduce to, the 2's are gone, that's just going to be an x squared. Let's see, those x's are gone, minus 3 halves there. And then plus, that's going to be 2 over x. And I am going to leave it as 2 over x, because remember, whenever I have an x to the -1, that's kind of a trick for me, because I don't want to have to divide by 0. So I leave it like that, because I know I can use an ln in there. Okay, so then, once you are ready to take the integral, you add 1 to the exponent, divide by that number. Okay, for this, there is no variable, so I could just tack on a variable. And then this, remember, whenever it's a number over x, it's going to be 2 ln of x. And we should have our absolute value markers there. And don't forget a plus c. And I would leave it just like that. Okay. And I will kind of pause there before I start the next video.